A heavily contaminated 75-hectare site of a former oil refinery is to be remediated for its future use as an innovation campus for promising innovations in the automotive sector. In 2017, a joint venture of Zyplin Umwelttechnik GmbH, Geiger Unternehmensgruppe, and Strabag Umwelttechnik GmbH was contacted for this comprehensive remediation project.
As a general contractor, our consortium is also responsible for the selection of appropriate remediation methods, permitting processes with the competent authorities, detailed planning, documentation and the execution of the remediation works. The overall goal is to release the property from the register of contaminated sites. Each successfully remediated part of the compound will be handed over to our employer, who is then able to commence construction works.
Remediation procedures which are highly specialized are employed to meet the tough time schedule and large cubatures of contaminated material. In the downstream direction of the remediation area, the precious Danube wetlands need to be protected from contaminated runoff from the site. Hence, in advance to the remediation procedures, a hydraulic barrier formed by a series of 10 wells was erected on the southwestern boundary. Up to 210 cubic meters per hour of contaminated groundwater is produced and treated in 4 treatment steps, until the water is so pure to being re-infiltrated in the area of protected biotopes. With air sparging, volatile contaminants are extracted from the subsurface. Air is injected deep into the groundwater aquifer, which then percolates upwards. On its way to the surface, the air is enriched with contaminants and extracted just below ground level by fully automated plants.
The method of air sparging is applied on an area with a size of approximately 16 football fields or 120,000 square meters. 8 air sparging plants operate around 500 injection wells, and each of them is independently controlled according to its actual remediation status.
A low-emission strategy is employed to remove petroleum-derived hydrocarbons in the saturated zone. In the first step, hexagonal sheetings are forced into the subsurface, driven by a leader-mounted vibration device. In the second step, each steel sheeting is excavated with a clamshell bucket, reaching a depth of 7 meters below groundwater level. After the contaminated soil is removed, the empty hexagonal sheets get backfilled with clean soil in the third step. Handling of contaminated and non-contaminated soil requires appropriate site logistics. In the last step, the hexagonal sheetings are extracted, only to be re-injected in the adjacent contaminated area.
To reach our target performance, we need a coordinated team and a specialized equipment. In this project, we will execute this sequence of 10 of thousands of hexagonal sheetings. With our method, we can reliably exchange the contaminated soil with little emissions and without overlap.
A total of 500,000 tons of contaminated material needs to be excavated and backfilled with non-contaminated soil. The method of soil washing was reinvented for this purpose, which is perfectly suitable for this site's pollutants and typical grain structure. The soil mainly consists of gravel. In the reception hall, up to 1,200 tons can be fed into the washing facility each day. Contaminated soil is broken down into its compartments and then scrubbed with clean water.
More than 90% of the input material can be reused on site for backfilling. Soil washing gets applied for the first time at this scale for material with traces of PFC. Given the extremely low target values, we yield perfect washing results.
The polluted water and sludge from the washing process gets treated in a closed cycle, such that 380 cubic meters per hour of clean water is readily available as a washing agent. The contaminants are concentrated in the filter cake, and by that, disposal quantities are extremely minimized. Before filling, the washed soil is transported and raised to piles. The material is then sampled and analyzed by independent consultants. For an augmentation of the surface level of about 1 meter in thickness, 1 million tons of clean soil have to be imported and handled. On some days, up to 200 trucks arrive at the site.
We move 10,000 tons of material each day on the site without interrupting the remediation efforts underway. This requires a tremendous coordination effort with every section of our remediation project. Naturally, each transaction is documented without a gap.
Remediating a recent site of a mineral oil facility is an elaborate task, where innovative technologies are applied under challenging conditions and on an impressive scale. Future generations should be able to use the site without risks for their health and safety.